$1,000,000 question again, and maybe you know. Now, how does? Now, let's assume you are in model program. Let us say, hi, how are you? This is your model program, and then there is an Excel program. You copy from here. जी आपसे पूछ, you copy from here and you paste here. It is pasted here. You are editing. How does it happen?
So you modify our Excel file.
Excel file. It means you are copying from here. You copy.
एड्रेस स्पेस में जो चीज पड़ी हुई थी उसको हमने उसको एक्सेस
कॉपी किया और यहाँ पे पेस्ट किया. जी. Now there should be a memory protection, but operating system is allowing it. Why he is allowing it? You got my point or not? जी.
सर इसमें हम कुछ अपना डेटा जो है वो क्लिपबोर्ड के थ्रू भी तो करते हैं ना.
Yes. Yes. So it means that there are two type of things. There is two type of address space. One is a private address space and one is a shared address space. So this is private address space. Private address space, and now there is some shared address space, and that shared address space is actually clipboard. So actually when you copy it, you are using an API in operating system. It is copying from here and clipboard, and when you paste here, so the other program is actually reading from there, and actually this shared is allowed by the operating system. Why it is allowed? It is actually allowed to allow inter-process communication, inter-program communication. So if one program wants to communicate with other program, but with the permission of the operating system.
So it's mean to clipboard है वो भी memory location लेकिन वो shared है.
वो shared है. So actually the shared space is allowed, but it's not allowed. Now I'll give this with an example. Now let's say everybody students is here. It's your pouch. Okay, it's your personal pouch. Maybe you have personal data, your ATM card, your wallet, maybe your secret things. These are your personal data. She should not be allowed to access it. Good? Agreed? Even he is not allowed, and vice versa. Okay, but if you look at this board, you can write on this board. You can write on this board. You can this. So this is a shared thingy. It's a shared thingy, and it's shared by all the students. The things that are shared in this class, what are these things? Lights are shared, fans are shared, computers are shared. For instance, these are something that are shared. So actually, if you look at these things, so this is also now we have now another thing. So I will rephrase my stuff again. That operating system will not allow any program to access the private address space. Not about the shared address space. And this shared address space is sometimes important for inter-program communication or inter-process communication. When one program wants to communicate with another program, so it will allow it. Now, memory allocation is done, memory reallocation is done, memory protection is done. Now, operating system also allows access to the shared resources. There are some shared. Can you give me some example of shared resources?
So memory सबसे बड़ा shared resource है.
Memory is a shared, but now it has been covered by the topic of the memory management. Now we are done with the memory management. Memory is a shared resource, memory protection, and that's done. Another example of shared resources.
सर हमारे पास multiple cores जुड़े होते हैं तो processor जो है वो भी shared होता है.
It's also a shared resource. It's also a shared resource. But if you look at, let's assume if you are working in an enterprise environment in which there is a printer and this printer is connected with all the users, so it's also a shared resource. Okay. Now let's assume now at the same time there are two users. Lal say, what's your name? Memula. You have sent a file of 10 MB, you have sent a file of 15 MB. Maybe this is OHT1, you want to print that OHT1, or you want to print your assignments. Okay. Now the problem is that you both of them send them at the same time. Now, if the printer prints half page of your data and half page of your data, just assume a scenario.
मिक्स हो जाएगा.
Mix हो जाएगा. Now listen. Now if you see, now if you're sending some data, you have written some like it's your page 1, and it's your page 1. Memuna and Lal say page 1 of Lal say if on the first page how did I split it from here and how did it from here and how from here and from here. If it's intermingled, would you like to allow it? Should allow allow access to the shared resources, and it makes sure. So actually, if you look at like maybe you have seen it when you are working in an enterprise environment, when you print it. So there is a print server, and on the print server there is on some of the files that are on the queue update server, print server. Okay, and that file and actually it will give some priority. Maybe there is a first come first serve. So actually, when file 1 is completed, then file 2 is maybe your file is 100 MB and you have sent it first, and your file is 2 MB, you have sent it second. So it will all of your pages. Sometimes ये होता है ना कि सारे पेज जब तक प्रिंट नहीं होता आप वेट कर रहे होते हैं. ठीक है, तो यही होता है. It also allow access to the shared resources, and in a shared resource when you are using a shared resource, so operating system will first lock that shared resource for one of the user. When it's locked by one of the user or one thing, so it means the operating system is saying, okay, now if you say, now if you look at this device, so this device will have some status. Not just maybe this device or any shared resource. Maybe generalize it. It can be any shared resource. So this shared resource has some parameters. So we say this shared resource is now busy, or these shared resources are free. This is one bit, it's called busy or free. So when it's 0, okay, if it's 0, it's busy, and if it's 1, it is free. Either it's busy or free. Now if it's busy or free, now if it's free, okay, operating system will allocate that shared resource to any program who is requesting. So what the program will do? If you remember, when you go on the Word file and you click on the print, when you click on the print, it is also an API.
Yes, sir.
Then if you look at the print, then your page will be on which printer, P1, P2 or P3, P3. So actually you have installed the drivers of that printer.
Yes, sir.
It will actually give that file to the shared resource, that's the printer, and with your user ID. With your user ID. So actually, when it's free, okay, no program is currently sharing the resource, no problem. But when you send, only one user is there. So operating system will allocate, it will change its status from free to what? Busy. And that shared resource, okay, and then there is a PID. PID is called as process ID. Which of the program is now the access of that resource? So now this is this PID. So actually there is one program like Microsoft Word, Excel. Maybe this PID is 0x523. Maybe this PID is 0x921. So 0x523. So which of the devices now using the printer? What is using? When it's done, the status changed from what?
From busy to free.
Busy to free. And then when it's free, so the PID does not matter anymore. Then it can be allocated. Now if you look at this, now let's assume a scenario in which there are multiple users and we have sent, there are 5 or 6 users have sent files to the printer. It's not only multiple files from multiple users, it can be multiple files from the same user. So for each request there will be a process ID. For each, maybe the same user, let's say has sent one file in Word and one file in Excel. When you have sent it, so actually some process ID will be assigned to that task. This is a task. Some process ID will be assigned, and when some process ID is assigned, it will be maintained in the queue or the memory of the print file buffer when it's done. And it's in which format? It's not in Word format. It's not in PDF format. It's in the format that is being understandable by the printer. Because printer does not know this. There is Word or print. Printer knows pixels.
Yes, sir.
Pixels. Now if you look at the pixel, you say A4 size. The pixel size for A4 will be different. The pixel size for A3 will be different. The pixel size for A2 will be different. Then there is also color annotations.
Yes, sir.
So actually when you say the print, so actually the word is actually converting your data into a format that is understandable, that is recognizable by the printer. So which format? I don't know what will be the format. There will be some coding and how this like okay, this is start of the frame and what's the pixels. So if you look at the this one page, like you are saying, if you say hi and this is in green and then hi, I am Fazal, this is in red, so actually this will be pixel information that will be given to the printer if it's a color printer. If it's a color printer. And even in the grey printer, there are some dark and light grey, depending upon the color. So in which form it's a color printer, so the actually the driver will interpret it. So actually it's the actual binary file that will be sent to the print will be different from the grey printer. So all these things are hidden from the user. From the end user it's hidden. But from the program perspective there are some APIs for that, like printf or something. But when you are printing a file, into which format you are printing the file, in which format? So there is some printf format. How does it does? Somebody who has written a program of Word, he knows it, how it's done. Okay, so then operating system allows access to the shared resource. Done. The shared resource can be printer or scanner or so forth. And then it also allows control access to the file. Can anybody elaborate what is the control access to a file and why it is needed? Why it is needed? Control access to a file.
सर कुछ फाइल्स हैं आपको ऐसी होती हैं इम्पोर्टेंट होती हैं उसके हर एक को एक्सेस नहीं दी जा सकती.
Yes.
कुछ एक्सेस दी जाती है, कुछ बीच में ओवरराइट कर सकते हैं, कुछ बीच में रीड कर सकते हैं, कुछ उसको
Why it's required?
वो प्राइवेसी होती है फाइल की.
Why privacy is required?
इसलिए कि कोई अनऑथराइज्ड यूजर्स उसको चेंज नहीं करते.
Why it is required? No, yes, there should be some logic for it. Now, a personal computer is actually maybe their privacy is not that much important because it's protected by the user. But when you are using, in a system and that is being shared by multiple users, maybe let's say maybe you know that in IST you have multiple users. In IST,
Yes, sir.
multiple users. When they log in, you can log in on any PC, on any lab PC, and you have your own space. So it provides a control access to your file. So nobody will be allowed to access your data. Nobody will be allowed to access your data. So actually in this control access file, each file has some protection, like read. Some people is allowed to read, some people is allowed to write, and some people are also allowed to modify. Read, write, modify. These are different access rights. These are different access rights. Now let's assume if I'm sending some like I'm sharing some file like, to the student, and actually they are not allowed to they are only allowed to read the file, but they are not allowed to write the file. They are not allowed to modify. And some files are also password protected. So it's the highest level of security.
सर जिस तरह हम लॉगिन करते हैं सर अपना कंप्यूटर पे, तो जब मैं स्टूडेंट लॉगिन से करता हूँ तो मुझे पब्लिक फोल्डर का एक्सेस नहीं होता, जो SOPs होते हैं जो ईमेल में आपके साथ
Yes.
आते हैं. लेकिन जब मैं अपने फैकल्टी लॉगिन से लॉगिन करता हूँ तो वो आ जाते हैं.
Yes.
लेकिन जब उस फाइल को मैं एक्सेस करता हूँ तो वो प्रिंट नहीं होता. तो जो प्रिंट नहीं होता तो उससे रिलेटेबल है.
Yes,
हम इसको-
because it's also whether you are not only whether you are allowed to print or not. Not only one parameter, there are a lot of parameters. You are allowed to access that file, you are allowed to share that file, you are allowed to print that file. There are a lot of access. Okay, so these are all of the parameters that you need, and all of this done are printed. And sometimes it's also like let's assume now you have not worked on the Linux environment or the Linux system. Let's assume I have created one folder on the embedded system. All the students are logged in, and these are then user, student A, student B, student C, student D, and student M. There are M students. each student has its own folder. This A should not be allowed to access the data of student B, but being as a teacher, I may be giving all.
इस तरह टीम्स पे क्या होता है?
Yes, yes. There is access, shared access team. So maybe the teacher is allowed to access. So it's also depending the access rights. So the operating system allows to access rights. So actually, I have created this folder. So I have an access rights. I have access right of read, write, and modify. And maybe if I want to save some shade, I also declare some shade, and it can be viewed by all the students. So they can read it, but they cannot modify. Okay, he is not allowed to read here or write here or modify. Only the students. When you will click on student A will click on this, so it will be password protected. Okay, enter your password.
इस तरह गूगल ड्राइव पे भी हम शेयर करते हैं,
Yeah.
उसमें हम
Now it depends on maybe now it depends on the system. Now if the student is logging on that system, so he will be allowed to access folder A and share. Even on the same system, user B is logging on the same system, not on a different system.
yes sir,
He will be allowed to access
B only B and share.
and share. And if the same faculty member, he will be allowed to access.
B.
Depend on the operating system, depending upon the access management. And these access management for these, there are some scripts of the access management, who is allowed or who is something like that. So next, if I created this thing, I click on the folder, I say read write permission, and then I say okay, or user A or user B or user C. All these things are control access to the file, and actually it is done in an environment when some kind of resource or the PCs are shared by multiple PCs. And actually the data is not stored on that. If you look at all the data is not stored on that PC. It is stored on the cloud, some centralized location.
Yes sir.
Actually, if the same student log in on another PC, will be still allowed to access A. Let's assume if he enters in PC1, and then he modifies some file, and then he log into PC2, he will access the same data.
Same data. इनको सर्वर को एक्सेस कर रहे
This is
हैं.
servers. So this is all the mechanism that which is done. So actually, who is doing this? The control access to the file, operating system, and there are also some kind of like API mechanism that how there is when who is creating that file or who is like, let's assume and now if you look at this, like if you look at the complete system, okay, now this is an example of a distributed operating system. Distributed operating system that is visible to all users at different PCs. There is one system administrator, and that system administrator is doing all these tasks. System administrator, and who is designing this system administrator? And actually, in each university, there is a policy for the system administrator. He knows the rights. That okay, what are the faculty rights? What are the rights of the students? Okay, what are the rights of the student? What are the rights? And he knows the policy, and that policy is given to the system administrator by the university,
Yes.
and he is enforcing that policy. He is enforcing that policy, and actually he gives these access rights to. Now let's say if you may also thought that there are also some in WhatsApp group, there are also some groups in which there are admins.
तो सिर्फ एडमिन ही पोस्ट कर सकते
Then admin can post and another party can post. So actually WhatsApp also allows these things. So if you look at this, all these things are like happens in our daily life. All these practices are made. So operating system also create the program. So whenever a program is created, so it also does the program creation and it also execute the program. Why when you click on the program and you are executing, so it's actually creating a program, and operating system also does the memory, the program execution. Like there are multiple programs, and operating system is a shared resource, so it gives the time slot to each individual program, give time slot to each program. Okay, now I will continue to now. Next. मेरे पास एक 20 मिनट का एक और देख कर लेते हैं ना, उसी बात में ठीक
ठीक है।
अभी इसको ना करें ना, ठीक है। Okay. Now, what is a process? Process is a program in execution. Now, we have also defined that it's a program in execution and it is an entity to which a microprocessor is required. It is an entity to which microprocessor is allocated. Now let's assume a scenario that there are multiple processes. Okay, and that needs to be executed on a processor. So if we assume a single processor scenario and there are 5 processes, P1, P2, P3, P4 and P5. So microprocessor at a time can only execute one process at a time. Now if you look at there are 2 types of modes of the mode. One is the kernel mode, that is run by the operating system, and another is the user mode. And in the user mode there can be multiple processes. Okay. Now if we say that initially when program P1 is running, operating system allocates time to process program P1, then it is switched, the operating system will run and it's in the kernel mode. Then the control is transferred to process P2, then operating system is running, then P3, then P4, then P5, and let's assume it's a round robin mechanism, so then P1. So actually if you look at here, so there is a time slot, so operating system is given time slot, so it is given time slot to program P1. Time slot to program P1. If you look at this time slot, at this time slot, program P1 is running. Am I right? P1 is
running.
In this case, which program is running?
P2 is running.
And instead, P3 is running. Now, each process has different states. So, in this state, P3 is in running mode, and all other programs may be in new mode, or running mode, or waiting mode, or what are different modes? New mode. In the new mode, when the program is initially initiated by the user, so then it comes into the new mode. So what's the new mode? So it means when a program is initiated. What should we do in the new state? What should we do in the new state? What should the operating system do in the new state? Memory allocation. It will do the memory allocation. The whole memory or the active pages? Only active pages. So when the process is in new state, first it will do just the memory allocation. After this memory allocation, then the program will be ready to execute. But now there are different programs that are also running. So it also depends on when a new program is created. So actually there will be some queue of the operating system. We call it as a ready queue. Now let's assume this ready queue will look like this. First P1, P2, P3, P4 and P5. When the operating system gives time slot to this program, it's moved from here and then it's moved to the end. Then again the time slot will be given to the program P2. Then it will move to the bottom. So at the end. So this is the ready queue. There is another queue that is maintained in the operating system that is called as waiting queue. Now, ready state is done. So what's a ready state? So a ready state is the state when program is ready to be executed and waiting for what? Time slot. Is ready to be executed, but is waiting for its time slot or waiting for its turn. So in this case, now P1 is running, but maybe P2 is now ready. Now in this case, P2 is running, maybe then P1 is ready. It's ready to be executed, but it's not currently being executed. Agreed?
Yes, sir.
So when a program is initiated and the memory is located. After memory allocation, the program will move to the ready state. When it will move, so actually when it's new, we will do the memory allocation. When the memory allocation, the program will switch from the new state to the ready state. Okay, now when it will move from the ready state to the running state? It's very simple.
So जब इसका time slot आएगा
When time slot given by what? Whom?
Operating system.
When time slot given by operating system. Now in this case, P2 was ready, and the time slot was now given to P2. So the state of the P1 will move from running to ready, and P2 will move from ready to running. Okay. When the time slot is given. When it will move from the running to the ready?
So जब इसका time slot खत्म हो जाएगा
When time slot what?
finishes
Expires. When time slots expires. Okay. Now, when the program will move from the running to the ready state?
So जब हम कुछ input वो user ने कुछ input करना होता है इसलिए या कुछ इसको
When
memory से कुछ
program is waiting for some resource which is not available. One classical example is a page fault. Hard disk. You want some page from the hard disk, and typically loading that data from the hard disk to the memory takes some time. So the program will switch from the running state to the
Waiting state.
and it will be moved from the ready queue. Let's assume program P4 wants a page that is not in main memory. It will move from P4 to here. So even then, time slot will not be given to program P4. Why? Because it is waiting for the
resources.
source. And when it will move from the waiting to the ready state, when what?
जब उसे resource मिल जाए.
When resource becomes available. When resource becomes available. So actually, when the program will move from the running state to the halted state, when
जब इसमें
program finishes execution. When finishes execution, it is moved to the halted state. And halted state, what should we do now in the halted state? When it finishes execution, what should we do?
मेमोरी डीलोकेट करेंगे.
Deallocate. So actually, if there is now we are assuming a scenario there is a single processor. In a multiple processor, maybe okay, P1 is running a processor 1 and maybe P2 is running a processor 2. Now we are assuming only a single processor environment. In a single processor environment, so actually what is this? So actually this is in the kernel mode or user mode?
Kernel mode.
Why it is required?
So क्योंकि user mode में तो हम changing कर सकते हैं ना, तो kernel mode में changing नहीं कर सकते.
In kernel, what will be the responsibility in the kernel mode? It is called switching time. Why switching time is required? Because it will then update all the queues in the operating system, and all the queues are maintained within the operating system. It should not be a part of the program. All the statuses, the process states, all the process states, the process ID, each process has been assigned a unique ID. Now let's assume when you click on a program, a process is created for this program and a process ID is assigned. So let's say it's a Word program and you say process ID of that Word program is 0x2543. A process ID is assigned to that program. A process ID is assigned to that program, 0x25. And let's assume this is Word program. This is program P1, Word program. And let's assume 0x954, this is for program P2. And operating system has a queue of a ready queue. So if you say ready and 0x354 P3 P4 0x411 waiting. So if you say in the ready queue it's 0x2543 and 0x411, what does it implies? P1 and P4 are ready. And in waiting queue, let's assume 0x954. Which of the program is waiting?
0954 P2.
P2. Which of the program is ready?
P1 2143.